Hi, and welcome to this practice question for your quiz. All right, so you're going to have to show all your work on a separate sheet of paper and then box in your answer. There's going to be two answers. Then upload an image of your work using the image icon in Schoology, and we'll see how that goes. But you're here for the physics contents. It says vector A has a magnitude of 9 units and is directed south. Vector B has a magnitude of 15 units and is directed 60 degrees north of west. And they want you to determine the magnitude of the resultant and then the angle between north and the resultant vector. The wording is super important for that. So let's start by drawing our vectors. Vector A is 9 units straight down south. Vector B is 15 units, so it has a greater magnitude, and it's directed 60 degrees north of west. So here's west. We want a 60-degree angle north of west. So it should look like this. This is 60 degrees, and this is, I drew them like crazy like that on purpose. I'll connect them head to tail. This is 15 units. And vector A is 9 units. Okay, and the first step is to connect them head to tail. But really that's only if you were doing it graphically. But we can connect them head to tail. Make sure the 15 units is a little bit longer than the 9. And the reason I'm doing this is just to show you, okay, I start and then finish. So we're going to get a resultant vector that looks something like that. But we want to get the x and the y components first, so that we can find this is the real answer, the resultant vector. So it's multiple parts. We'll start by actually breaking this vector into its x and y components so that we can add it to our vector A. Now, vector A doesn't need to be broken down into x and y components because there is no x component. The x component is 0 units long. It's only the y component 9 units long. So the work is done for us there when we make our table. For vector A, there's AX is equal to 0 and AY is equal to 9 in the negative direction because it's in the negative Y axis going down. Okay, and then for B, we need to do some more work. B, I could tell right away, BX is going to be equal to B cosine theta, and by is going to be equal to b sine theta because this is adjacent, so we can use the shortcut, and this is opposite. So for the x component, we'll do b cosine theta. 15 cosine 60 is 7.5 units. And take a look, is the bx in the negative x direction or the positive x direction? If we were thinking of an XY graph, it's going to the left, negative. So we make it negative. For BY, we'll do B sine theta. And when you do 15 sine 60, you get 12.99 units. 12.99 units in the positive Y direction, up. So that's great because now we could get rid of this crazy vector that's at an angle over here. We can't add that to vector A, but we can easily add by and ay together. That's what we're doing over here. And we can easily say, well, the resultant vector is going to be this much in the x direction, and there is no x direction for vector A, so that's why we add it to 0. Ax is 0. So you just basically add the columns together, and that'll tell you the x and y components of your resultant. And then once you know the x and y components of your resultant, you could do Pythagorean theorem and inverse tangent. So 0 plus negative 7.5 is negative 7.5, and negative 9 plus 12.99 is positive 3.99. So these are the ones we're going to focus on. We could get rid of vectors A and B and make our resultant. So in the x direction, we want a vector that's going to the left in the negative x direction, 7.5. And in the y direction, we're going to do head to tail, positive, in the positive up direction, 3.99. Those are the two vectors for the resultant added head to tail, 7.5 to the left and 3.99 up. Sometimes I'll just not write the sign in. Why? Because the arrow is showing me the sign. So the arrow in physics is another way to say positive or negative when you're making these vector diagrams. The resultant looks like this. This is the answer. This is what we're looking for. So what is the magnitude or size of the resultant and what direction? Let's start by finding the magnitude by doing Pythagorean theorem. And with a little bit of rounding, you get 8.50 units. So this vector is 8.50 units long, but what direction is it going? So vectors, displacement vectors, or any type of vector needs magnitude, which we have, but also direction. And that's what part B says. It says, determine the angle between north and the resultant vector. If you found this angle here, that is wrong, because this is the resultant vector. So that's part of your angle. So that's part of it. So that's good. But is this north? No, this is not north. This is east. So you cannot tell me what this angle is because you're answering a question that I did not ask. You have to be specific when they're asking a specific question. So to do that, all you have to do is draw north on your diagram. And you listen, there's a couple different ways to do it. Could you find this angle first? And then knowing that it's a complementary angle with north, you could do 90 minus whatever this angle is. That's a totally valid way to do that. Or you could kind of reorganize your triangle that you made. You might have made it this other way first, and that would be more convenient for you. Let's rearrange some stuff here. And if you had put this up here, this is a totally valid way to make your components here. And then here, right now that looks head to head, the X and Y components. But what if you started by drawing up 3.99 and then over 7.5? If you had you happen to draw your triangle like that, then this question doesn't become that hard because you probably would automatically find this angle here. And you just happen to, yeah, oh, sweet. I automatically have north on my triangle, so that's convenient. Both ways of finding it, either finding this angle and then finding the complement, this one, or if by rearranging your triangle to look like this so that the y component is on the north right away, both are fine to find the angle. I'm going to do it this way, and I'm going to do the inverse tangent opposite over adjacent. And you get an angle of 61.987. Might as well just call it, you could call it 61.99 if you want, but 62 is fine. 62 is just fine. Okay, so that means the other angle must be 28. Is that right? Yeah, that's right. So if you said, oh, the answer is 28, wrong, but you could do 90 minus 28, and then you'd get to the right answer. That's what we're looking for. Okay, so that's for part A, and that's for part B. And it says box in your answers, right? So that makes it easier for me to pick out, because you're going to have a lot of work on your paper. If you box in your answer, then I know what your answer is, what you're telling me your final answer is, okay? So please box in your answers on the tests and quizzes. And, I would say good luck on the quiz, but you don't need it. You've been working hard the whole year. So show me what you know on the quiz tomorrow. Have a great day.